What the hell is this? You come to my house, Leonard, and you try to teach me phase shifts and trigonometry functions? Alright, we'll deal with that later. Just in a moment, anyways, because we really specifically have to do it this way. As a mathematician, you gotta be able to drop the hammer on this, not just train 0 and 1. It's just, let me dust it off before we get into it. Guy gets drunk and stupid with neighbor and calls him the N-word, north, the defined model of the trajectory on whatever triggered the trajectory. This guy, we keep moving this guy on the trigonometry. This thing's gonna spring that thing up there like the new mark of the beast N on his forward. Realistically though, let's get back and try to find another angle on this, which is the same angle. Over here, there's a presentation just raw on the board of trigonometrical values. Well, we use trigonometry to find an answer, right? So it's algebra, a plus b, combinations of x, y, and z, and phase motors. So any one of those work out. I just use the stone mill, but there's no reason you can't use what we're using last night, and parametric curves. Oh, landscaper's map. Well, because this is just the land. This is mathematically the land. It's just not... You can't map it in a bank. You can't map it in a stone mill. You have to map it in zeros and ones. So, now we got that off the table. Let's actually get into it here. Have to.
Introducing Lucia.
Explain it from here. It has to be done in zeros and ones first.
Simply find your target on LinkedIn.
That's why I said the phase gap there for this cell to this thing turning to this thing doing something to this thing doing something is trigonometry that tells time, right? This graphing index right here gives me distance, gives me values, and anywhere where I can now find that the trigonometry, the function can be propagated to come up, but it's still going to be ones and zeros. Can't be zeros, got to be n1 half. But as you n1 half that through, it's going to correlate to this number close to this number, even if they're radically different from each other, up and down, but they'd have an average as an operator. Inside that operator is a trigger. The weights and the plates could get a rabbit, could get the snake. What do you mean a deadfall? It's like, well, if snake's close to a rabbit next to that deadfall and it hits the trigger.
So in this video, we're going to talk about how to phase shift some trigonometric functions. And all that really means is a horizontal shift. We've talked about it before, and a lot of the college algebra graphing, even the intermediate.
You have to limit to 3 phases.
How to shift left
it winds up being a rocket
shift.
ship.
That's what we're talking about with the phase shift. I'm going to show you exactly how to work with it. I'm going to refer back to how we graph some trig functions without that phase shift,
2-phase,
vertical shift, and some
Elon space base.
That's about it. So let's talk about what phase shifting does. This is a horizontal shift along the x-axis, and we're going to see right away that that shift is going to be located right next to the x variable, which is really convenient. So x-axis stuff is right next to the x variable, which is nice. Now, if you remember anything about the horizontal shifting, the biggest thing that I can get you to know, these 2 pieces of information, is number 1, it's opposite of the sign that you kind of want it to be. So we oftentimes want to see plus as right.
See as a 0.
Adding next to
I'm not disagreeing with you. You'll get into it here in a second, but you'd have to quantify 1, 2, 3. Why? Why do we do it? Well, we do it because a horizontal shift along x. We need to know a horizontal vertical, horizontal shift along x winds up. 1 is 0 is 2 off the first index here, but it's still 0. It's like the second day, the third day, the fourth day. F is a force that applies to days like that. X equal the h. You're using Planck. If it is Planck, that's the easiest version that you can do, and that's why. And that could be 1 or 2 in here, I'm not sure, but it doesn't matter because 2x is 3x, which make 1x. As long as we subtract pi from this,
Then we're gonna
the globular
take a
state of
look at our
areas of
period.
particles
So
inside of
that's
there,
another
positive
reason why I wanted to
positives,
divide.
negative
We'll do that.
positives,
And lastly,
negative
we'll use our key
negatives,
points and graph
and
this. So we're
system.
gonna
Because
go
you'd be
right
in
into
here and
example
go,
right now.
whoa, that's a
Remember,
negative negative.
the only thing
That's
that
going to
is new
graph
right
a
now
time
is dealing
index
with a
inside of there
horizontal
that compresses
shift.
it. But this
Plus
is a
left minus
big
right
matrix,
is
which
called
again,
a phase shift
I
for a
just
trigonometric function.
parallel
So
it
let's
to
take a look at
hydrogen,
that.
helium, electron
If
shells.
we have 3 sine of 2x
Now,
minus pi,
why would I do that? Well, in the stone melt,
because we need that coefficient of x to be
hydrogen
1
is
to
everything. You
identify
can't
not
get
only
to
our
this
period,
composition
but our phase shift.
3
This is the first thing
sine
I'm gonna do. I'm gonna put it in
x
the proper form. If you remember
area
that with
pi
graphing, the proper
inside
form is very
here. It
important
just
for us. We like these
doesn't
things in certain
exist.
order.
They
The constants being added,
they
subtracted
do.
last. It's a vertical
Without
shift.
me getting too much into it,
Likewise, anything inside of our parentheses needs to have a coefficient of 1.
whenever I
So
found a
x. We're
positive,
gonna
that
force
based
this
it in
to divide
0
two.
and
So
1.
how do you
It's the
factor
first
out
time I
2?
run the trend
Or we
line,
put it?
it's
Number one
0.
thing,
That
don't
number
factor
won't
out
be the
2
same because I didn't
and
know the
put it
same.
there. That is not at all what's
Then
happening.
the one
So
step was the one
sine
step.
of this
Then I'll get a
thing,
lot of
that's an
broken
angle.
code in there
And so we've
before I
gotta
start
leave
making
that
it
junk
1
in
1
those
1 1
parentheses.
1
We're gonna
1
factor
1
out 2,
1
but
1
it's
1.
gonna remain
Now
inside
maybe a
that
couple of
function.
zeros on
We're
the
basically
approximation,
just
but it'll
gonna
get
divide both
compressed.
terms by
That's
2.
fine. Lots of stuff in the day comes up where I wish I could tell you your system was automated like that, but unfortunately it is not. It is not. If it takes electricity and you do not have a
And if
power
we do
plant,
that,
that would be a
2x
negative
divided by
one.
2 is just x,
Right?
or
That would
1x.
be,
That's what we
I'm
want.
trying to get in here to see what he's got on the left.
Now we're not factoring in
Right.
negatives, or sign isn't going to
You're making money, but it gets compressed.
You have to divide all the terms.
you know.
What you're factoring.
So what
2x
it helps you
divided
do
by
is
2
as a
x,
scientific
pi
or a
divided by 2
mathematician, I don't
is
care
pi
which
over
way you
2.
go, it just, I need an evaluation of
And
that. I
this
don't need
helps us
20,000 of them
identify
do it.
whatever
I just
phase
need to
shift is.
shake
This
out
is the
that one.
right form.
Which
This
is
what we do
where,
first.
as a
Now we're gonna do these
mathematician, these
steps
guys
when
are
we graph
teaching
it, but we
business.
wanna make sure it's of the
They're
right form.
teaching
This doesn't
somebody in the
break our
two-phase,
pattern
looking
here.
at the
We
boss
always make
saying,
sure our
hey,
functions are the right form before we
what
graph
I
it.
got to
And
do
that's what
in
we've got.
here
This is what we
to
want.
figure this
We've got
out is go do a comprehensive
factor for that
analysis
one,
of what
then a
this
trig
element
function,
is.
then an
How
x
it
with a
momentums,
coefficient of 1.
how it momentums or has decay into the state.
Now we're ready
Well,
to start identifying all of these
the number in
transformations.
itself at the
So
end
we
result
look for
is a
vertical
spring.
transformation first. We don't have one. A vertical shift would happen back there. There's nothing added or
It
subtracted
might be
to our
radical like
outputs,
that.
so
What do you
we're
mean?
not
It's like,
shifting
well,
up or down.
between here to
Then we go
here,
ahead
this
and
could be a
look for
common
horizontal
operator. But what if it
transformation.
happens
So
like,
whether we're phase shifting left or right, and this is where it's going to happen.
you know, the rocket
Right
ship
here.
doesn't have a
With
steady release
coefficient of 1,
of
that minus pi over 2
solid
is a phase
or
shift, a
liquid fuel.
horizontal shift
Maybe the
to
containment was
get
wrong,
it to the
or
right pi over 2.
it'll be obvious when you're there, you know, but you didn't have the framework to be able to catch it anyways.
If you have to write it out, you can write out that this is a phase shift right pi over 2. I typically just circle it and say right pi over 2.
Yeah.
Then what we do,
Mathematically, you'd say, what's on the left of this when we were doing his
is we draw those
parametric
so we're going to take a moment
curves
to do that right now. Now we don't have
an area,
this,
as I
this
did it
sort
from
of
the other day, and
vertical
you just
shift,
see a
so
little
I'm
bit
not
of
gonna be drawing
geometry
this sort
difference.
of new x-axis.
And, well,
but we do have phase shift, so I'm
x,
gonna redraw a
the square root
version
of t
a y-axis
here,
upon which we're gonna base
right,
all of our stuff.
what
Our
I'm
period,
using from
your
yesterday.
equals.
We got 3 phases here.
Now
I got
that
his
we've
work again
shown
on a
where that
line,
phase shift is,
and
so
I'm coming
this
cosecant
right
from
pi
back
over 2 is
in
okay,
like
this is where-
12,
this is where
15
we're
years
gonna
ago.
treat our y-axis
But
as.
the
Our key
paperwork
points are
all
gonna
looks the
relate
same.
that.
Math all looks
Remember
the same
that
like
our
that.
key points are based on whatever trig function you have.
This is
and
your
for
lead
psi, that means that we have x
because you
intercepts
have
at
to.
the ends
Now,
and center of the
I
period,
might know enough
and
because
key
I'm not
points
in this
at the
class to do
course.
that, which
Well,
makes
that's
it
how
different.
it would be based on
Just to cheat
this
this
is the
answer
start of
out,
your period. We
there
just
would be
phase
x
shifted
inside
to
of
the right.
here,
Treat
some stuff
this
y
like the
inside of
origin
here,
right
this
now.
would get dropped
And so
over
we're
there,
gonna
which
deal
make
with
a
that.
problem,
So
makes
we
it
said, hey, no vertical
compression.
shift. Yes,
That's
this
why he would have
horizontal
done it
phase
here
shift
because
to
that's
the
why
right
I've done
pi
it
over 2.
before.
Now
Clean
we
up
look
the
at our
system,
period and
break
base
it down
on
into
where our period starts now,
y
the shifted version of it.
has
So
1,
our period is
1,
always take a look
1
at your trig
instead of
function,
1
find the
t
period.
t over 2.
Sine
And
says
so
your
what I
period
was
is
talking
2
about
pi.
before when I was looking at that, when I say, well, this is the snowflake, what is
And
between
divide by
0,
the
I clocked in,
coefficient
to
of x.
1.
Well,
Well, I
in
got
this case, we
managers,
divide
I
by
got
1. So you're gonna
ground
divide
guys,
by
I got
whatever
the
that
first
number is,
move
that
is a
2.
very specific number for them. And it always is. It's like
And
the
this
guy
is gonna
clocks
have a
in, he does
period
this
of
set.
pi.
Those clock in sets
Now here's what to do
give
with
me
that. Because this
like
period
clock
is high,
in and do
but
stuff.
it no
Over the
longer
averages,
starts
you go to
here,
check
it
those
starts
things,
here.
and that's where
This
turnover
requires
rates
a
come
little
up
bit
about
more work for us.
people
So
not
we
working.
knew
I'm
that everything that
observing
Tangent
just
had
that
this
bit.
period that we
to determine how much I'm getting bit.
Really nice.
The bite.
But now we've started to shift. So here's what you do with that.
The one that does it right is the model I want to create after that system because they have the best standard.
Why we do it in this order? Take this phase shift.
They could do something in the positive projection that loses on the floor, but it's still positive, -1. That's all arbitrary. I get to make that decision. He makes that decision. And later on, because he's not really giving it here, you're off on the angle of it. You got to figure out where that is. Your area of 2 inside here is the same thing he did as all mathematicians and just like me. I have to be in 2. They had different sciences. T Model T, Ferrari.
So I've done that.
The breeding matters, and Tesla, right?
Period. So these things are going to cycle, of course. So you figure out your first cycle here.
But you notice how that was the answer?
Period. Now, because we know how sine operates, if you change the back, this is sine. We need to find the middle.
Oh, there's a. I go right to the harvest on psi. I go. It's.
So the middle of this is going to be pi.
You know, if you go too far on those, you start losing it in the crop. You go too early, it won't be IH the paste, or you would do a process with it. Let's say it is green, and you wanted to distill it moonshiner. If it wasn't harvested correctly off of that system too, then the results are going to be different. It's going to be more bitter. There's going to be more heads. There's going to be, I don't moonshine, but that's the only thing I can think of is it's mathematics is chemistry.
So a lot of the things that pop in our mind about sine
it's organic or
right
solid
now,
state.
With sine, the x-intercepts
we go organic first because
well, we have that now.
Organic is the person's versions of, if I don't have anybody else, it's whatever reaction flask I want. But in the turn state of solid state to like gaseous state is because you have to be, here you're trying to bottle this. This is already bottled. And even though there's a gas inside of here, it's in the form of a liquid, it's solid. It gives me a timeline, how long I can hold it before this piece of metal, how long it'll burn out, and plastic and butane, little few other compositions. They're all bits. One part is the striker or the flint, the spring. You know, I can high entropy, low entropy has to be. It's not really giving you an answer, but I'm telling you, it's like, am I dealing? What I'm telling you today, am I dealing with high entropy or low entropy right now? Well, this you would say is, well, this is low entropy because the parts are all together in one part. You're right, and I think against the room, it would be easy to say that, but did you see how fast that went? This got broken down into a whole bunch of different states, which is like putting it through the chipper. And that gives it really, really high entropy. And I got to know where those areas are for the people who don't understand that number out loud.
It changed, it grew. It did this vertical stretch into the first quarter, comma 3. Notice how I'm not saying 3, 5, or 4. Even though that is where this point is, that's fine. I'm treating this like just the first quarter of the period that it is. This is how I usually graph these trig functions. Works out really nice as long as you remember what sine does.
I wish I could see one of his works.
Quarters of first quarter 1, third quarter -1. That's our key point, and then we can start modifying that.
Well, it's Bernoulli. That's why Bernoulli worked.
Really all there is to it. I think
Gresham's law on
this isn't that bad
pi over 2. Give me 0. It zeroes that clock right out. So most commonly, and that's why you give them that answer. It's like most commonly. It's not all the time this. It'll change and do other crap on you, bits and bytes, zeros and ones. Data compression. And so if it's students across the board, Berkeley hammered that one. It's the integral of infinity, big, infinity, small. Integral on big and small, 2020, 2021, minus bracket. This bracket right here would be students are the stone mill, students are that. I'm separating that index to just the groups inside here, which, oh, I don't either. That's where this gets funsies. It's almost like they play some stuff in there. Now, I don't know your students and how that works, but let's get back here to see if I can find something and say, it's like, well, I always did it on the stone mill.
Half of that period would be 2 pi.
is always going to be day-night cycle for sure. There's no way you can escape that. It's going to have a spike on there. It's going to have what that is. Obviously, this is day on the nights. You know, but this is also hydrogen. It really is. Let's look at this wave function. Just one arc is neutrino. Two arcs inside of here, durium. 3 tritium inside of there. But it actually makes sense to why it would do that. And the human brain would do it like that. This is a lot of Maxwell's, Rayleigh Jeans, vibration, frequency, amplitudes. They had a problem in... You watch Space Time.
Phase shift, and that will create your first period for you. After that, identify what trig function we're working with. I'm only going to show you sine and cosine. You can't do this with all the other trig functions, but I think I've made it very clear that cosecant and secant are based on sine and cosine, so it's not bad. And then tangent and cotangent, you can also phase shift. So we deal with our period, add that to it, and then deal with your key points.
So, well, he's right, because you're not going to need this much of it. This is already described. It usually takes people like this to
get ready to mark it off,
turn it over,
and step it up.
So what I did here in the
so we have another graph that we're kind of doing right now.
Vibration, frequency, amplitude of Planck's. Planck is going to be IH, right? This H is the smallest number possible, 6.63, which is arbitrary for what it needs to be because it's hydrogen. You're not doing hydrogen. But I'm still trying to catch the black body on this snowflake of positions, orientations. Without it, mathematically speaking, they start to vibrate under that nu mu. Oh, where is she? What am I doing here? I want this one. Alright, so we're on this side first.
4x divided by 4 is x, and 3 pi divided by 4 is just...
And I'm trying to determine a frequency in which that mathematically applies to some of these heavy-duty concepts. So,
all of our transformations and write them out, which I'm not going to show you. That's not the purpose. The purpose is to get these things
energies of constants. It winds up kind of being this big bad nasty before Einstein dropped in E, H, nu, right? He's saying the capital form of energy is the smallest number, which is something new. I can have something like a class and graph students, but this new group of students kind of correlates to phase shifts, right? And then I'm dealing with the amplitude, frequency, and vibrations, air acoustic flutters that this building has. Now, what is air acoustic colors? I use it in the stone mill as the screw bolt for the maintenance logs. And so it just wobbles for a few weeks and then it gets out, and then if you're not paying attention to that wobble, it'll be whenever it wants to foul is when it'll foul. Not when I can range 3 inches on that length of that system to say at that point in time, not only did that happen, but if we keep letting that happen twice, it'll start to burn out the rails. So we want to replace it when it's at that index, that approximation inside of there, which is a bit. Just a 1 and a 0 when the IH observable number make a wave function for it on psi, right? Because psi would tell me a wave function on the system. Well, here we use actually lambda. I use lambda. But psi comes up a lot. It's just Maxwell's, or excuse me, Schrodinger's, Gresham's law on it. We're not here. Let me do this from Corey Leonard. We are not here to do the esoterics, the eschatology of who the devil is. You are. It's calculus. It's mathematically Leonard, me, you, because we're an idol under it. Somebody's going to lead to us, and there's somebody's going to say we're a Murphy. That's what stuff gets you in trouble inside of the screw bolts. How often, how loud, and why. So we're going to leave it at that.